Hey everybody, Mr. Barry here, solving quadratics by factoring, kind of starting from the bottom, working our way up, and hopefully here early on we'll do some things that you're somewhat familiar with some new tie-ins to Algebra 2, but we're going to solve these equations right here. First equation, x squared minus 5x is equal to 0. The second equation, 3w squared plus 15w is equal to 0. So a couple things to note real quick here. The first thing is that these are quadratic equations. The biggest exponent is 2 for each of these. So not that we can't see something that has an exponent bigger than 2, but here we have exponents bigger than 2. There are 2 terms on the left side for both these equations, and the equations are equal to 0, which in the previous video we talked about how important that is, and we want that. So not a lot of thought process in that. We have our equations equal to 0. I want to solve these equations. And before I do that, I want to kind of point out that they are in standard form. So when I'm talking about standard form, I'm talking about just the left side of the equation, the side that does not include the equal to 0. So right here I have x squared minus 5x. Now remember, when it comes to standard form, we know standard form to be ax squared plus bx plus c. So we know that to be the case. That's something that we had in the last unit. So if I look here at x squared minus 5x, okay, just to practice here a little bit, because we're going to need this as we go along. All right, our a value here is in front of the variable squared, that's 1. Our b value is the coefficient in front of the variable, that's negative 5. And again, if I'm just looking at the left side, there's no constant there. So technically, since there's nothing there, we can go ahead and say it would be 0. So our constant on the left side here for the first equation would be 0. Real quickly, let's also check out the second one here, just so that we practice. We have a quadratic equation here. We want to go ahead and label what standard form A, B, and C would be. A value here is 3. It's the coefficient in front of the variable squared. Our B value is 12. It's that coefficient in front of the variable. And then again, over on the left side here, we don't have a constant value, and that's okay, no big deal. That just means that our constant here would be 0. So with that information being said, we talked about in the previous video here that the very first thing that I always want to do is I want to make sure that I check for a GCF. So I see a quadratic equation. It involves some sort of factoring here. I want to check and see if I can figure out a GCF. So factors that are in common with each of the terms here on the left side. For problem number 1, I have x squared minus 5x. So I'll take a look at the coefficients, 1 and negative 5. Is there any number that I can think about that would divide evenly into both of those other than the number 1? And there's not, especially if there's a number 1 as a coefficient. That kind of tells you that you're not going to have a GCF here. We don't include the number 1 as part of that because it really doesn't do anything for us. It just keeps the identity. If we look at the variables, though, in the terms up here, we have x squared minus 5x. We should notice that on the left side, the variable x repeats itself in both terms. So because we have that constant, or excuse me, not constant, we have that in both terms, then we should be able to pull that out as a GCF. So here in this problem, up at the top, our GCF is going to be x. So I'm going to just notify myself of that my GCF is x right there. And that will be pulled out of this situation. So there's my x right there. But now I have to figure out what's left over. So I pulled the GCF out, that's x. And whatever's left over from pulling that out, I'm going to put inside these parentheses here to kind of notify myself what's going on. So x squared divided by x would be x. And negative 5x divided by x would be negative 5. So if I kind of worked my way backwards from this, and you use distribution here, another Algebra 1 thing that you were able to do here, x times x is x squared, x times negative 5 is negative 5x. I'm just simplifying this, and again, trying to kind of sort of make it look like it's an intercept form here to help myself later on in the problem. Let me stop on this problem. Maybe you already know the answer to this, but let me go down here and do the same exact thing. I'm going to try to figure out what the GCF is first, because I know I have to solve this equation. So if I take a look at the coefficients, my coefficients here are 3 and 12, and I think to myself, is there any numbers other than the number 1 that would factor into both of those 3 and 12, a number that would divide evenly? And hopefully you understand that the number 3 does in fact divide into 3 evenly and 12 evenly. So when it comes to my GCF here on the bottom, I have the number 3. I also want to spend some time talking or thinking about the variables here. I'm sorry about that. The variables here. In the one term I have w squared, and the other term I have w. So there is a repeat in variables here. 2 w's here, 1 w here. So the greatest common of factors, the greatest amount of w's that are involved here, by both that are in common, would be just 1 w. So my GCF for the bottom here is 3w, and I want to go ahead and take a moment and pull that out. I'm going to put parentheses to kind of notify myself what would be left over after I pulled out the 3w using division. 3w squared divided by 3w. Well, 3 divided by 3 would be 1. That would be our coefficient here. W squared divided by w would leave me with 1w left over. Then over here, 12w divided by the GCF 3w. 12 divided by 3 would be 4. And w divided by w would make the number 1. So we have 4 left over there. And again, if I work myself backwards, it's always good to check yourself here. 3w times w would be 3w squared. 3w times 4 would be 12w. So I have these two equations here, and I've factored, but I haven't solved the equations yet. So I've certainly done the GCF, pulled that out. We kind of simplified things. You can kind of notice if I stuck this in parentheses and stuck this in parentheses, it would in fact look like intercept form. And at this point, I want to use the zero product property to figure out what's going to go on and what the solutions would be to this equation, or these equations. So zero product property here tells me I'm going to set the term on the outside, x, equal to 0. And there's really no math work there to be done. It's x is equal to 0. And I'm going to set what's inside the parentheses equal to 0. And I have x is equal to 5. And again, that process you've done an awful lot of here in this class in the first 2 months. So maybe that's something you already knew the answer to, but now we kind of have it set in stone here with the equations. So we definitely have to use that zero product property to calculate what the answers would be here, the solutions to this equation. Down here, a slightly different story because we have a coefficient out in the front. We would take that factor. It's the greatest common factor, 3w, and set it equal to 0. And we would take this fact over here, w plus 4, and set that equal to 0. 3w is equal to 0. Again, if we're trying to solve this equation, I'd have to divide 3 to both sides, and w would be equal to 0. Over here, I have w plus 4 is equal to 0. And if I solve that equation, I would have w is equal to -4. So for our first problem here, we got that x is equal to 0 and x is equal to 5. For the second problem down here, I got w is equal to 0 and w is equal to -4. Please remember what that means. If this was a picture on the graph and we're solving an equation, what that means is that if I took the number 0 here and plugged it in, I would get a solution of 0. And if I plugged the 5 in, I would go back to the number 0. And if I plug down here in this equation 0 in here, it would be equal to 0. If I plugged -4 into this equation for w, it would get me to 0.